Hey everybody, we're live and in studio. Let's do redox theory. Now, please understand that you are not supposed to do question number 1. It's from moles and stoichiometry, but since I'm solving this very late, some students made mistake when compiling this. So if you've not taken moles and stoichiometry yet, you can skip this question 1. But I'm going to do it because you guys who are in the live class, you have already taken moles and stoichiometry. So let's solve it. Hydrated rhodium 3 chloride catalyzes the conversion of ethene to butene, both stereoisomers. What are stereoisomers? I don't give a shit for now. Hydrated rhodium 3 chloride contains 20.5% by mass of water of crystallization. That's the water of crystallization, right? The water molecules bonded to a hydrated salt or present in a hydrated salt, right? Now, it's saying if 20.5% is of this, if 20.5% is of this, what is the percentage of rhodium chloride? Total percentage is always 100. So if I write rhodium chloride right here, and if I write H2O here, well, how much percentage is H2O? 20.5%. How much is rhodium chloride? 100 minus 20.5%, right? So what do you get? 79.5. Thank you. Then what's the next step? So you know percentages are just like grams. We consider percentages just like grams. And he's saying calculate X. Pretty simple. It's just asking you to calculate the empirical formula for it, right? So what do we do, sir? What do we do? Divided by the molar masses, which is what? 18. And this is what? This is 209.4. Thank you. How is it 209.4? You can also explain this. Rhodium is 102.9 plus 35.5 times by 3. And this should give you 209.4 like the student said. Here. What do you get, sir? 0.3796. Okay. And what do you get here? 3796, sir. 3796. What do you get here? 1.1388. Then divide by the smallest ratio, which is what? 0.3796. 0.3796. What do you get? It's 1 ratio 3. So the formula is what? What is X? X is 3, right? And the formula is RHCl3.3H2O. Now, some of you guys might fight with me and might say, sir, this is not how we used to calculate X for hydrated salt. How did we used to calculate X for hydrated salt? Effectively, this is the right method to do so. Right? It's basically empirical formula is the right method to do so, right? But if you want to stick to the old methods from O levels, and even, I also teach that from time to time. If you want to stick to that, you could think of these as grams, right? Because percentages are just like grams. So 79.5% is RHCl3 kilograms. And for H2O, it's basically how many grams? 20.5 grams. What are the steps that we take? So we convert both into moles, don't we? Mass equal mole times molar mass, right? Mass equal mole times molar mass. So mass is 79.5. Moles we need to calculate. Molar mass is what? 209.5. So how many moles do I have? Again, the same. 0.3796. How many moles do I have for this particular case? Mass equal mole times molar mass. 20.5 equals mole times, what's the molar mass? 18. N is equal to 20.5 divided by 1.1388. These are the moles. And then what did we used to say? We used to say, hey, if you have RHCl3 and you have H2O, for 0.3796 moles, you have 1.1388 moles of H2O. For 1 mole, you have XH2O, right? So if for 0.3796, you have 1.1388. For 1 mole, how many moles of H2O would you have? X cross multiply, what do you get? 1.1388 divided by 0.39796. What do you get, sir? You should effectively get 3. So both methods are absolutely correct. You could use this one, you could use this one. This is the one that we've been using since O-level IGCSE, but the reality behind X calculation is the empirical formula. And effectively, you are doing that. You are doing that. If you compare these two, those who are interested in why these two answers are correct, we effectively do the same thing on the left that we do on the right. Right? Can somebody confirm this? Oh, it's okay. It's okay. But calculator usage, I can't help you with that. If you press the wrong button on the calculator, you're done for, right? So be very careful. Write the numbers in the boxes to balance out the equation. I swear to God, it's a piece of cake. See, how can you balance it out? It's just a 1-mark question. You have 1 chlorine on the left, you have 3 on the right. So what should I put here? 3. What should I put here? 3. Now you have 3 sodiums on the left, right? And you have 1 sodium here and 1 sodium here. Now, if I were you, I would not even think, and I'd add just a 1 here and a 2 here to balance sodium. Why a 1 and 2 here instead of a 2 and 1 here? That's the $1,000,000 question. See, I need to get 3 sodiums, don't I? I can either get 3 sodium if I put 2 and 1 here, because 2 sodium and 1 sodium from here, or I could get 3 sodiums if I put 1 here and 2 here. The problem with putting 2 here and 1 here is that if I put 2 here and 1 here, the problem is that then this fella is disturbed, and there is no bracket whatsoever for me to balance this. So then this is not balanced, which must mean what? Which must mean, my dear friends, that there's a 1 here, and so this is pretty basic common knowledge question. There's a 1 here and a 2 here, and that's now good stuff. So everything is balanced. Then you just need to balance here. You already have 3 Cls on the left, you have 3 on the right, and just put a 1 here, and you'd see everything will be balanced. Everything is balanced. That's it. So next, nitrogen and phosphorus are elements of group 15 of the periodic table. A common test for nitrates is the reaction of NaOH and Al. This is basically the aluminum foil. Remember, you used to study this in O levels and IGCSE. Aluminum foil, warm it, and have NaOH as well. You're gonna get a pungent smelling gas, and you could test for that gas, and that's ammonia, right? So you're seeing it shows the reaction. It shows the reaction, and I'm gonna put a steric here, because students who ask me how this reaction takes place in O levels, I'll show it to them and scared the living hell out of them. So I will remember this equation now. Reduce the oxidation number of the nitrate ion. Pretty simple, it's NO3 1 minus. Nitrogen is X, oxygen is minus 2, times it by 3 because you have 3 oxygens, plus, what does that give me? Overall is minus 1. Overall oxidation number of any ion is its charge, which is minus 1 right here. X minus 6 equals minus 1, X equals plus 5. My advice to you would be to write plus 5, although you'd see in the marking scheme 5 like this is also going to be written, but my advice to you guys would be to write plus 5. It's okay, same thing. Identify the species that is oxidized in equation 1. So which species is oxidized? This is plus 5, you literally calculated it. This nitrogen right here is minus 3, and now it should be on your fingertips. Why is it minus 3? And I don't know, hydrogen is plus 1, you have 3 hydrogens, times it by 3, add them, overall oxidation number of any compound is 0, and any X is equal to minus 3. So this is minus 3, and you'd see that nitrogen is effectively being reduced, right? It goes from plus 5 to minus 3. It goes from plus 5 in NO3 minus to minus 3 in NH3, right? So what should be oxidized? It should be aluminum, which is oxidized, right? Aluminum goes from 0 to what? Now, if you don't know that, you could even guess it and say, hey, it's aluminum, because the other substance is nitrogen is being reduced, so it's going to be aluminum which is being oxidized. But if you want to actually figure it out, it's Al, OH, 4, and minus, right? So how do you calculate this stuff? It has an overall minus. How do you calculate this stuff? Well, aluminum is X, I don't know. Oxygen is minus 2. Hydrogen is plus 1. Times it by 4, because you have 4 of these. Add them together, because the overall oxidation number of any ion is its charge, so it's minus 1. X minus 2 plus 1 is minus 1. Minus 1 times 4, that's what? Minus 1 times 4 is minus 4, equals minus 1. X is equal to plus 3. So it's absolutely being oxidized. It goes from 0 to plus 3. Yeah, pretty basic. Acha, one crucial question that I want to ask you. In NO3 minus, if this is plus 5, what is the oxidation number of oxygen? Again, I always do this in Redox because I want to crush any confusion. G, what is the oxidation number of oxygen? Minus 6 or minus 2? And I've stressed a lot on this in the live classes. Yeah, come on, Shabash, I want everybody's answer. Please, I want everybody's answer. Not just Aisha, not just these 3-4 students who are, we are quite a couple of students. Minus 2, okay, minus 2, okay. And you all are wrong. It's not minus, it is minus 2, you dumbo jumbo. Whoever is written minus 6, I'm not going to ask your name. I'm not going to, say your name out loud. Please go over Redox. Your concepts are messed up. Because I've gone over this, oxidation numbers are for every one of that substance, not for every 3 or 4. The reason why we add them is to calculate the overall oxidation number. That's why we do separate working always. I don't write it on top. I don't write it on top because I don't want to confuse students. That's why we always do separate working. So please, mar jayenge ये Dettol की बोतल मजाक करूँ. So Mg3N2. You could take this 2 back up, take this 3 back up, and you could say, hey, Mg had a charge of 2 plus and N had a charge of 3 minus, and therefore the oxidation number of magnesium is what? Plus 2, and for nitrogen is minus 3. And you'll see in your in some of the marking scheme it's written like plus 2 like this or minus 3 like this. I don't recommend writing it like this. There's a reason to it, because examiners change and their mood swings change, so I don't care. And the reality is not taking this up and up. The reality for Mg3 and 2, and since you're in A levels, everything should be conceptually clear, which is what the reality behind it is. You need 3 magnesium ions for 2 nitrogen ions. That's the reality. See, 6 plus and 6 minus. The last question for the 2024 theory set. Okay, last question. Bi2O3 can be used to form, this is basically bismuth oxide. So bismuth oxide can be used to form sodium bismite, maybe, as shown in equation 1. Equation 1 is shown. Reduce the oxidation number of Bi in Bi2O3 and in NaBiO3. So it's pretty simple. Bi2O3. See, you could have 2 ways. Bi2O3. Right? There are multiple ways to do it. Some ways are to take this 3 back up and to take this 2 back up, right? So what would happen if you take the 3 back up? Bi would have a charge of 3 plus O is 2 minus, so Bi in Bi2O3 is plus 3. That's one way. The other way is to say, hey, you need 2 Bi ions and 3 O2 minus ions. Now 3 O2 minus ions is 6 minus, and this should be 6 plus. What should I write here to make it 6 plus? 3 plus, because 3 times 2 is 6. So multiple ways. And the third way is, see, there's so many ways to do it. If your conceptual clarity is there, there's so many ways to do it. The third way is, say, hey, bismuth is X. You have 2 times bismuths. Oxygen is minus 2, times it by 3, because you have 3 O's. Add them together. Oh, sorry, I've already added them. Overall oxidation number of any compound is 0. 2x minus 6 equals 0. 2x equals plus 6. X is equal to plus 6 divided by 2. That's what? Plus 3. Multiple ways. And NaBiO3, you could do it, in a lot, and again in multiple ways. I'll just take the bismuth ion, BiO3 minus, because if this is NaBiO3, I know that Na is 1 plus and BiO3 is minus. That's why the formula is NaBiO3. For one Na, one BiO3 is required, right? So it should split in your brain directly. This is X, let's suppose, I don't know. Oxygen is minus 2, times it by 3. The overall oxidation number of any ion is its charge. X minus 6 equals minus 1. X equals plus 5. And I do not recommend writing Roman numerals, please. Although your examiner would have also written this, would have also shown this, I don't recommend it. It's up to you. You can write it. I don't recommend it. Identify the reducing agent in equation 1. So which one is the reducing agent? This had the oxidation number of plus 3, and then it went from plus 3 to plus 5, right? So which one is the reducing agent? You see, what Bi2O3 has done is something really brutal. It oxidized itself. Bi2O3 oxidized itself and reduced oxygen. It oxidized itself and made oxygen go from 0 to minus 2. So what is the reducing agent? Reducing agent is BiO3, because itself it was oxidized and therefore it reduced oxygen. It gave electrons to oxygen and made it minus 2, and itself became oxidized. So reducing agent is the chemical which oxidizes itself to reduce others. Or you could have the simple rote learning that your teachers have taught you throughout O levels and A levels, that hey, whatever is oxidized is the reducing agent, whatever is reduced is the oxidizing agent. But I want you guys to visualize how it has happened. Bi2O3 has given electrons to oxygen and itself was oxidized and gave electrons to oxygen and made it go and reduced it. So it's a reducing agent, because itself was oxidized, reduced this fella. And that's it. 2024 set for redox is also done, and so is it done for states of matter. Do you know why? Because there is no 24 question for states of matter, at least not in my booklet and not even in the exam. So it's highly anticipated in 2025 and 2026. I think in 2025 it was tested. I don't know, I'll have to check the 2025 papers. I haven't yet checked it, but if it's not even tested in 2025, start expecting it in 2026.